All right, so in 5.2, oh, that's some terrible yellowing color. All right, we are factoring quadratic polynomials today. So we want to factor a common monomial from a polynomial. We want to factor trinomials. We want to use those patterns. We've kind of already talked about those to factor special products. And we want to write and factor quadratic polynomials that represent real-world situations. So first up, factoring is a method of expressing a polynomial as a product. It is the opposite of multiplying, if we could get the pen to work. Okay, so it's the opposite of multiplying or the opposite of distributing. Excuse me, thank you. It's kind of like dividing, but not. Yes, it's like dividing. Reverse multiplying, that's a good way to describe it, yes. So the first step is to factor out the GCF. This is always, always, always your first step to see if you can factor out the GCF. What is the GCF? Greatest common factor. Okay, so typically we talk about the GCF of numbers. Okay, like the GCF of 20 and 12. Now that you're in algebra, we are going to talk about what's the greatest common factor of 20x and 12x squared. The variable can be as well in your GCF because they have an x in common. So what's the greatest number between 20 and 12? 16 doesn't go into either one of them. No, factor. You're talking multiples. Factor is always a smaller number. A factor is a number that goes into both of them. No, we want the greatest common factor. We agree with 4? 4 goes into 20 and 4 goes into 12, right? So we take a 4, we're going to take a 4 out. But then this one has an x, and this one has an x squared. We can take an x out. And so we're going to, in doing that, well, we're going to say, well, if we have a 20x and we take a 4x out, what do we have left? A 5. You just divide the two numbers. So if I have, so this one would be 3x if we were listing them. Yeah. So the greatest common factor is the 4x, and we factored that out, and it left us with 5 and 3x. You can totally do that. That's exactly what we're going to do. Yeah, at any point. You have to leave the 4x in it. You can't remove it completely. You have to pull it out just like it was. No. We're not magically making numbers disappear. So let's look at the example 1 here. We have 15x squared plus 45x. What's the greatest common factor? Try again. 15 would be the great. But if you did it the other way, you'd find you were wrong. Like you'd find out you were wrong. So let's see. So we've got 15 is the greatest number. And then what else do they have in common? An x. So 15x squared divided by, so 15 divided by 15 is just 1. I'm going to write the 1. That's highly unusual. What's x squared divided by x? X. Okay, plus. What's 45 divided by 15? I would just put x in the future. Yeah. 3, and x divided by x is, it's no x, right? Because it's just a 1. We don't have any at that point. So yeah, so it's just 15x times x plus 3. Now, if we looked at like what you said, it was 5. That's okay. If you pull out a 5 and an x, you'd get 3, right? You could just do it again. Exactly. Because then you'd get this. And you'd be like, oh, wait, I can still pull out another 3. So you would have, if you needed to write it, you could say 5x times 3, because you're pulling that 3 out, would leave you with 1 plus 5x. Or wait, hold on. Oh, yeah, thank you. The x plus 3. Thank you. So yes, you would just do it a second time. And that's okay if you have to take 2 steps. Yeah. Yeah. That works. Okay. So then B is different. If we look at B, okay, so we have these this problem, 2x times the quantity 3x minus 7 plus 5 times the quantity 3x minus 7. These two things are what they're in common. They're identical, right? 3x minus 7. That's called the common binomial factor. We can actually pull those out. So if we say, yeah. I said because those are identical, the common binomial factor, we can pull those out. And then what's left behind is 2x plus 5. So if this wasn't here, if we pulled it out, we factored that out because these are the same. So we factor that out, and what's left? 2x. You can only do that if they're the exact same. Only if they're the exact same. So yes. One is minus 7, one is plus 7. Not the exact same. Yep, you can't do it if one is minus and one is plus. You can manipulate it so. Yep. Yep. You can just pull it out, and then what is left? 2x plus 5. So then we say, okay, so times that times 2x plus 5. And you're because it's the other binomial, because it's what's left. Well, but we factored out what was there that was in common, and so this is what's left, and so we put it, because this has to be distributed to this, because it was 2x was being multiplied by that quantity, and 5. Yeah. Well, and so that's the thing too, is that if we look at it, the way it was being done is 2x was being distributed to 3x and negative 7. And now we're taking it, we're still going to distribute it, right? We just wrote it different. That's exactly it. Because it's fun. It's fun to write things different. It is. It's so fun. Okay, that's awesome. I feel like you have a good handle on that. So let's look at factoring quadratic trinomials. So when we have ax squared plus bx plus c. All right. Now, this is when a equals 1. So if a is 1, you're actually looking at the equation x squared plus bx. Whoop. Pardon me if I could write. So I'm just saying, when a is equal to, we're looking at this equation when a is equal to 1. So really, there's no a even there. Like you're given the equation, and it's going to say x squared plus whatever. Other times it is going to say 4x squared or 2x squared or 9x squared. So there's the different strategies when when a is 1 versus when a is a different number, whether it's a fraction or a whole number. Okay, so this is the fun part. It says, so when we have this, we want to identify two factors of c. So this is my c value, right? Negative 21. This is a problem. So these are the steps, 1, 2, 3 steps, and this is our first example problem. Okay, so the top thing wasn't part of the problem. That's the formula, how it's set up. Good question. Yes. That's a quadratic. That's the setup of a quadratic formula, or a quadratic equation, or a quadratic trinomial, actually, and then we'll get to an equation when we add an equals to it. So this is a quadratic trinomial. So this is an example one. So we're going to find factors of c, negative 21, whose sum is b. So they have to add to equal, so we have to find factors that add to equal negative 4. Because that's how we find the binomial. Okay, so let's make a list. Okay, so negative 1 times 21 equals negative 21, right? Any 2s? 3s? Okay, so we could do, the other thing I have to do here, let me back up for just a second. We're going to walk through all these, is this could also be 1 and negative 21. In all fairness, we'll write those out because they have a different sum. So then we could have 3 and -7, or we could have -3 and 7. Are there any other ways to get 21? No, there's not. So which of these gives me a sum of -4 if I add them? 3 and -7, because 3 plus -7 equals 4. Perfect. Thank you, -4. Appreciate that. Okay, so we did that, 3 and -7. Now, we write the factors of the x squared as the first terms in two binomial factors. So we just split them up. So we've got our parentheses because we want two binomials. We put the x as the first fact, or the first term. And then, step 3, write the factors you found in step 1 as the last term in each binomial. So I'm going to say, well, x plus 3 and x minus 7. And you are done. It is okay to be confused. Because here's the thing. This is the binomial that we multiply. We FOIL to get this trinomial. So if I took this, x plus 3.
So all we did was reverse FOIL?
Yep. That's what factoring is. Because there's a time when this is what, I mean, like there's a lot of times, not a time. From here on out, there's a lot of times where we're going to have it in this form to be able to solve for it. Yeah, so you have to suck things out of it. You're like your own personal Hoover vacuum. Okay? But yeah, because this is the point. We took it to a binomial so that if we turn around and factored it to check it, we'd have x squared minus 7x plus 3x minus 21. X squared minus 7x plus 3x would be -4x minus 21, which is what we started with. It's the same. So we know we did it right. Okay, because eventually we're going to get to solving a quadratic equation. Okay, so we're going to have this x squared minus 4x minus 21 equals 62. And you have to be able to solve so we can get it into this form of like x plus 3 times the quantity x minus 7 equals 62. And actually this is not entirely correct, but to give you an idea. And then we can go from there. We'll teach some other strategies to solve, because a quadratic is, we look at the graphing way and how to solve it as well, algebraically. And so then we can find some other things from that. So we're getting to that point to solve. Okay, so let's try another example. This time we've got x squared minus 11x plus 24. All right, so again, we need factors of 24, and it's a positive 24. So let me include that here. Factors for the positive 24, because that's my C value, that sum or add to be -11. That's my B value. No, the factors of it that equal this, not the GCF. So this is a little bit different. Okay, so like factors of 24 are 1 and 24, 2 and 12. Well, so, right, because if we looked, is there a greatest common factor between these three terms? But if I look at the whole thing, is there a greatest common factor? No. So when there's not a greatest common factor, this is like the next step.
You have to find all the factors.
Yes. Once you find it, you put it in that binomial form. And so you don't have to use you don't have to find all of the factors. Like I'm listing them out so we can talk about them. But like if I said, 1 plus 24, well, that's the same thing as 24. or 25, pardon me, right? 2 plus 12 is going to be 14. Okay, so I know that those aren't it. I'm listing them so we can have this conversation. You don't actually have to write them all down, but we do need to know. So what are some other factors of 24? Like 3 and 8, right? 3 plus 8 is, 11. So we need to make it -3 and -8. It gives me a positive 24, right? -3 times -8 gives me a positive 24. But when we add them, -3 plus -8 gives me a -11. So we're going to use -3 and -8. So then we just say, okay, so this is x minus 3 times x minus 8. And you are done. That's it. That is your factored binomial. The x came from this x squared, right? So we had x here and then an x over here.
So that's why the a equals 1 or whatever. And that's why x is squared. So you just pull one of each from the other.
Yes. Yes. Okay. So let's flip over to the back. All right. Okay, so this is factoring the quadratic trinomial. Okay, same thing, ax squared plus bx plus c when a is not equal to 1. So that means you are going to have an a value. You do have an a. So this first example is 12x squared plus 5x minus 2.
So you know if a is 1 or something else if you have a number assigned to your x squared.
Then yeah, then you know it's
So
something.
that's how you know it's equal to 1 or not.
Yeah, if there's no number in front of x squared, then it's you. A is just equal to 1. Okay, so in this case, all right, so in this case, we identify two factors of AC. Okay, that's different. So we have to take this number and this number. Not at this point. Well, we are, because then we're going to say whose sum is B. So, but we have to multiply these. So we have to take 12 times -2, and so that's -24. So what factors of -24 get me B, that positive 5? Absolutely. Okay, so this time we have a number in front of the x, right? We've got a 12. So now we have to take the a and the c and we multiply those together. So we're going to do 12 times -2. That equals -24. And now we find what factors give us that positive 5, that b value. So if there's no number in front of the x squared, we just use the c. If there's a number in front, we have to multiply them and do it. Okay. So again, if we go through with -24 and we're trying to get 5, okay, so we've got 1 and -24 or 24 and -1. Those are going to be much bigger. A -3 and a positive 8, okay, because -3 times 8 equals -24, but -3 plus 8 equals 5. So that's it. Okay, we're going to use those factors, -3 and 8, okay, to rewrite the middle term as a sum of the factors from step 1. So this is going to be 12x squared minus 3x plus 8x minus 2. We're just rewriting the middle this time. Yes.
Is it decagon? Does that have 10 sides?
Yes. Okay. Big. Because the next step is to group the first two terms. So I'm going to group these together. Okay. And the last two terms. So the positive 8x and the negative 2. And then I factor the GCF from each group. Okay, so I break it. So I need 4 terms so I can make it into a binomial. When I had the 3, I couldn't do it. So I split that middle term into 2 terms, so I had 4. So my GCF here, 12x squared and minus 3x is 3x. Okay, so 12 divided by 3 is 4. X squared divided by x is x. And then it's negative 3x divided by 3x is negative 1, right? Okay, so my next one, 8x minus 2, what's the greatest common factor there? 2. All right, so I'm going to have it's a positive 2. 8x divided by 2 is 4x. Negative 2 divided by 2 is negative 1. Yeah. Now, look at this. These are those common binomials that we had before. That should happen every single time. You should get a common binomial that you can pull out. You can factor out that common binomial, and then you combine what's left. So what's left is 3x plus 2. Right there. And then you're done. You have your 2 binomials. Are we hating life? Or are we like, okay, it's not so terrible? It's okay, you're just really tired. Okay. Let's try the next one then. 7x squared plus 11x minus 6. I'm going to just slide my paper over there so I have some free space. Okay, so what 2 numbers do I multiply together?
7x squared minus.
Okay, so I'm going to do 7 and negative 6. So 7 times negative 6 is negative 42. All right, so what are my factors of negative 42 that are going to give me 11? I personally, I always look here. Well, 7 and 6, I already did that. What is 7 plus 6? Well, this is true. It'd be 7 plus negative 6, right? Negative 1. But if I think about it the other way too, 7 and 6, if I added them, is 13. So it's close to there. I'm like, okay, well, maybe it's close to 7 and 6. Maybe not. Because like you said, it's negative 1. But we know 7 and 6 are out. What was it? Okay, but 21 times 2, like a negative 2, that's too far away. That's out. So it needs to be bigger than 7, but smaller than 21. Hey, what's a number? What's 7? It's got to be bigger than 7, but smaller than 21. What's the 7, the multiple of 7 in between there? The multiple of 7. 14. So this would be 14 times negative 3. And that would sum to be 11. So those would be our factors. Okay, so we did not get to the word problems today. So yeah, you're probably not going to get to those in your homework.
I'll do my best, but I'm probably going to have a lot of questions come Monday.
Okay, well, questions are good. Questions are good. So let's see. Oh, but I only gave you one word problem anyway in the homework. Oh, nope, I didn't even give you that one.
There's not a lot of homework, but I'm going to do my best. I'm not sure that I will.
So if you get to one that has a trinomial that's, like we did a couple examples, so go ahead and try those. But these are the ones that I would expect you maybe to struggle with more that have, because we only got the one example. But you're welcome.